Hello everyone, welcome back to the workshop, and today we are looking at something completely new to our workshop. That is a fiber laser. More specifically, we're looking at the ComMarker B4 20 watt fiber laser. They sent this out to me, asked me to take a look at it. I was excited. This is the first time I've been able to use this style of laser. So if that's something you're interested in, we're gonna jump right into it. I have had this in my shop for a couple of weeks, but being my first fiber and galvo style laser, I've been learning a lot through this. So don't take everything I'm saying as gospel. If there's something I'm doing wrong here and you have more experience, please, by all means, help the whole community out, myself, leave a comment down below. But keep that in mind. I'm a laser enthusiast. This is my first time with a fiber laser, so I'm learning along just as with you, but I tried to make sure I had enough of an understanding to give other newcomers a chance to learn about it as well. So as I mentioned, this is the ComMarker B4 20 watt galvo style fiber laser. And so what that means is it has a galvanometer that is a series of mirrors that sense the current and deflect that beam onto the working area. It has the lens that brings this down to a very precise point, and those mirrors can move very fast. So it means that you get some very high speed and high detail, but it also reduces your working area down quite a bit. This does work off of the 1064 nanometer infrared wavelength, so it can interact with metals, most synthetics, but your natural materials and your clear materials, it's going to struggle with as well. So this laser does work in the 20 to 60 kilohertz frequency range. It has a 0.01 millimeter spot size for precision of focus as well as movement. It also operates up to 15,000 millimeters per second as far as the engraving speed. And with that, they state you can get a maximum of 0.3 millimeter max depth engraving on most materials. Now, it does come with two lens options. There's a 110 by 110 millimeter lens, as well as a 200 by 200 millimeter lens. So the difference there is the 200 millimeter lens is going to widen your work area, but also enlarge that spot size. So for less detailed work, but larger areas, you can up your speed a little bit, maybe get a little more working area, but you're going to lose just a little bit of your detail. This laser does come ready out of the box with EasyCAD 2. That is got all the features you need to operate this, but if you are a Lightburn user and want to upgrade your license to the Galvo style, it does support EasyCAD 2. You can set up this machine in there and work with all your existing files, just migrating them into the setup that you will need for this laser. So as you know, this channel, I like Lightburn. I've upgraded my license and I'm going to be rolling with that. Now this laser does have a few extra options with it. It comes with a foot pedal for repeated markings so that you can set up your jig, place your item in there, hit the paddle, and it will do an engraving. And then finally, it does have a hoop. You can take the head off the base unit. It does have a fairly long cable. You can use this handheld up to larger objects, maybe on the wall or face down. We'll try to check that out, but I'm not sure I'm going to get to that in this specific video. But it is a cool option if it's something you're looking for and needing in your workshop. So this laser came well packed in, double boxed and well insulated by your typical Kaizen type foam. So you'll want to take your time, pull out all the parts, make sure everything's there and accounted for. There was a minor damage to the shipping box, but luckily the way this was packed, it actually came out okay for me. I had no damage and was able to easily get the parts out of the box. The build is fairly simple. They do have a one-page in the manual on it with photos to walk you through, as well as they do have some videos to help you through either on the SD card or on their YouTube channel as well. I'll try to link those down below, but you pretty much need to attach the tower and the coupling, the focus coupling rod to the base, and then you attach the head to that, and then you put the handle on top for your manual focus, plug everything in and make sure it's all aligned square, and then you're good to go to start installing the software. So here, let's take a quick tour of the exterior of this laser now that it is assembled. As you can see, it is basically an all-in-one unit. You've got most of your electronics and your power supply, your fiber source down here, and then it does have this wire loom material that is feeding everything from the base up to the top unit here. Like I said, this does come off. There are 4 Allen head screws down here. You can take that off, and then you can affix this focus hoop and steadying hoop on here. You attach this to down here. You'll adjust the height, and then that sets your focal length to the base of this. They do include these 2 brackets here that allow you to do a quick jig. All these holes down here are threaded for these Allen head screws, so you could customize your own jigs as needed, or use these to kind of make a square for repeated cuts. As I mentioned, they do come with 2 lenses. So attached to the machine natively was the 110mm lens, but they also do have this 200mm lens that you can swap out. I do wish they had maybe a carrying case for the lens that you're not using, so that might be something just to keep in mind. You're going to want to have some way of keeping this protected when not in use. So that is why I have it still kind of in the bubble wrap, just to keep dust and debris out of it. Now with these lasers, of course, safety is important. There's a couple features on here. First and foremost, they do provide a set of glasses. Now these do look better than your typical glasses that have come with other diode lasers and such. I was told that some of the early backers were sent just a normal set of colored glasses, but they said they were going to upgrade them. And so they do look like a nice quality. They do have side guards, and there is some kind of mirroring effect to that. However, I would still like to see the documentation. And normally on most laser lenses that have been rated, there's going to say something along the lines of the wavelength, so nanometer wavelength, as well as an optical density for how much light they actually block. That is not on here. There is a little QC tag in here that just says QC pass. Doesn't really have any extra information on there. So I can't even really speak to what they're supposed to be rated for. They look nice, but I have no documentation saying that this is specifically what they're rated for. This is my eyesight we're talking about, and so I'm still going to default to my purposefully rated, and they're marked right on the lenses what they're rated for. That gives me a better sense of confidence that they are going to protect my eyes. Now, if you don't have anything else, go ahead and use these, but do yourself a favor, keep your eyes and your sight safe. Make sure you're using appropriate safety gear. As far as other safety gear with this laser, it does have an e-stop button right on the front. If you push that forward, that's going to kill the power, kill the motion, and then you'll need to twist it to reset it. So in the case of something messing up, you can hit that, and that should shut down whatever's going on. As you are marking with one of these, it is going to be creating airborne particulate as you're ablating metal. Some of those little metal dust and that heavy metal stuff can get airborne. You don't want to be breathing that in. So you either want to have this in some sort of enclosure that's going to be capturing that. At minimum, I'll show you in a little bit, a filter that's trying to draw air out. But in any case, if nothing else, put a respirator on, use it with positive airflow. It's going to keep it moving away from you. But it's always best to try to capture that particulate with some sort of filter. So looking at the back of the laser, as I mentioned, we have our umbilical for the power and the fiber laser source to go up to the head. We also have our typical PC port power cable. Mine came with a US plug on the other side. And on this side, we have our USB cable. So this is an A to B cable. The B side plugs in to the laser here. The A would go into your computer, but they do provide you 2 USB A to C adapters. So if you have a newer laptop that does not have USB A connectors, they've got you covered as well. Nice little extra touch. It's nice to have these adapters to help adapt to other things. And then you do have a couple of these barrel connectors on here as well. One is for the foot pedal and one is for the rotary adapter that they can screw in to the back here and help you control those as well. And then coming around back up front, we do have a few buttons on here. We have our overall power button. And then on the base here, you have raise or lower buttons, just an arrow up, arrow down. That will help you adjust your focus. And then on the top, you have an R and an M. So this would be for red dot framing. It's going to either outline your whole object or it'll actually do a preview of your engraving on there. And then the M is for mark. That would be to, once you have your framing good, you hit mark and then it will actually fire the laser on that. As far as alternate focus then, we do have this hand crank that will allow you to manually turn this and that will raise or lower the head as opposed to this, just giving you a little bit of finer control as you're getting the focus. We will show that a little bit closer as we get to it, but you have 3 dots that need to come together. Once they're aligned, it is in focus. So you can do it manually or you can use the electronic controls on the base. All right, so that's a nice overview of the machine itself, what comes with it. And now let's jump into using this. I'm gonna set this up in Lightburn really quick. I'm not gonna go through that in this video because it would get really long. But maybe in the future I'll add setting this machine up in both EasyCAD and Lightburn. But for now, I have a lot of sample material to test. So let's jump into that. We'll go through each one a little bit, showing the settings and how it burns. I'll try to show some real time, but also speed some of them up. And at the end, we'll see how they all look. I've moved our alignment tools, our acrylic ones, down for this business card. And over here in Lightburn, you can see I've set up a simple business card file. So it's got my logo, it has my email, just the icons of where people can find me. And then this is within Lightburn, they have their QR code generator. So I have this pointing off to my YouTube page because that is kind of my primary source for information. So now you'll see I have a couple of layers here. We've got our layer cut, and then we have the tool. The tool I'm using kind of as an overall outline. And so if I turn on the framing here and switch it back to bounds, you probably can't see it too closely, but I have this just lined up on the outside. And then if I switch to contour, it's going to kind of give me a preview of all the items in there. So that's how I kind of lined up this jig. And the nice thing now is I'll be able to slide one card in there and then move on to the next and have it be in alignment. Again, we've done our focusing with the up and down to get our dots as close as we can together to ensure that the head is focused as well. Now these are anodized aluminum cards, and I did some playing around with the settings to try to find something that's pretty close. And so I'll show you here, I have crosshatch set up, so it's going to go side to side, then up and down. Now, of course, I could adjust the scan angle on that if I wanted to, but we're going to leave it at that. Lines per inch, I've got the line interval at 0.05 millimeter. Again, that's pretty fine, but we're going to try to get a pretty solid fill on these anodized aluminum cards with the fine focus spot of this. Sometimes having a little overlap helps. It takes just a little bit longer, but you'll find that you're less likely to have little imperfections. We're running at 10,000 millimeters a second. Maximum power is 75%. And yeah, we're going to roll that. Oh, and then our frequency over here is kilohertz. So I do like the setup in Lightburn for adjusting layers here. We can do everything here rather than doing hatch and then parameters. And then the second, I've got this set up as a multi-pass. Second one is just a line to go around really quickly and outline it. 5,000 millimeters a second, 20. That just kind of helps crisp up the edges of any fill as possible. Let's go ahead now. In Lightburn, if I hit start, it's not going to burn right away. It's going to bring up the frame window. Again, we can double check our bounds. But in here, we can go ahead and hit start. Let's do that and watch this go. And there you have it. One business card done in less than a minute. And then if I wanted to, I could drop another one in, hit start, and it would fire it off right away, just the same as the last. All right, so if we wanted to enable our foot pedal in Lightburn so that we could do repeated cuts, as I mentioned, we've got our framing set up here. So if we wanted to slide this out and then drop in another card and then just hit go without having to mess around with the computer, we definitely can do that, but you do need to come into Lightburn and change some settings. All right, so we're going to come over into Lightburn and we're going to go into our device settings. So you can either click on this icon, this wrench and screwdriver up here, or you can go to edit and device settings. And you're going to see you have a number of I/O ports up here. Currently, I don't have anything extra set up down here, but if you notice when I hit the pedal here, number 4 lights up. So that's our I/O port for the foot pedal. So what we want to do is we want to adjust this start marking. We're going to change this to 4. If you normally you'd have it set as none, we're going to change this to 4, and then we're going to hit OK. Now we don't have any card here, but we still have the job set up, and I'm going to go ahead and slide a card in there. Now without touching anything in Lightburn, I'm going to come over here and I'm going to hit the foot pedal. Now just like hitting start in Lightburn, it's going to bring up our framing first, and then if I go ahead and hit the pedal again, it'll start marking. Again, it's done one card. Slide that out of the way. Program's still set up. I hit the pedal again. It's going to start marking right away. There you go. We got a second card. We've got a few cards now. We could definitely just sit here and batch them out just by running over, swapping the cards, hitting that pedal. All right, so one of the fun things with fiber is you can engrave and on metal, and in this case we're using some stainless steel. This is actually just a stainless steel outlet blank that I picked up at the local store, which, you know, they're fairly cheap if you don't have any stainless steel sheet. Good way to do some playing. So once again, we're gonna start by adjusting our focus, getting these as close as we can. And then what I like using Lightburn for is we have our material tests. So we're gonna come up to our laser tools, open our material tests. And I was doing some playing around, but let's see, let's get the right one here. Stainless steel color test on fiber. We're gonna see if we can get some color out of this. I did a little bit of research online of what other people had found, and I came up with some settings here. And we're gonna be using the upper frequency range, so we're going from 50 to 60, and then we're going from 10 to 100% power, and we're locked in at the 750 millimeters a second. And our interval is going to be 0.003 millimeters. It's really small, but that will hopefully give us the heat and the frequency range to do this. So I really like using Lightburn. It sets up these grids for us really well. So let's go ahead and hit our frame button. Let's get the contour, the bounds. Actually, let's make sure that we're all on here, not on any of the curves. So right about there. We'll bring you in a little bit closer over here. Get our dust extraction going, and let's send this off and start the color test. All right, here are the results of it. As you can see, it's very dark on top. And in the bottom, if we get the right angle, you start seeing a little bit of color. So what I think we need to do is actually speed this up. I'll try running it again. But you're just starting to see a little color in the baseline. So I think it's just a little slow. But this is where these material tests really come in, because you can kind of see the gradient forming until we get up here where it's just really blasting it out. And from there, we can dial in what we are going to do. So let's try just speeding this up once, see if we get any different results there. And if not, then we need to start playing with our frequency as well. All right, so we sped it up, and as a matter of fact, I kind of feel like we're getting less color out of this. So obviously we're going to need to do some playing around more with the speed and power settings. And the thing with this is it's really about the temperature and annealing this. So just because it works on this piece of stainless steel, you're going to grab a different one that has a little bit different composition, a little bit thicker. It absorbs the heat differently. So that's one of the tricky things about playing with color on here. It's going to be very material and environment specific, but this gives us a good starting point range for doing some marking on things, and an example of what you can do with stainless steel. All right, so not only can it engrave vectors, but you can take a bitmap and do more photorealistic engravings, and it does have a fairly fine point detail, so we should be able to get something pretty good out of this, even at such a small scale as this little dog tag here. So you've probably seen this before on my channel, maybe. This is a Stormtrooper selfie that's been going around the internet, and being a bit of a sci-fi geek myself, I like to play around with these photos whenever I can. And so we will go ahead and let's look at the image settings here. So I've got it set up in Stucky mode, and I've kind of increased the contrast quite a bit. I've increased the enhance amount and radius a little bit. Actually decreased the brightness, played with the gamma to kind of get this a little more, you know, really offset effect. And so We've done that and we've got this set up. So if we come over here and frame this, I don't know if you're picking that up, but we have just the red outline just inside there. So let's go ahead and run this job and see how it turns out. And there you have it. It actually came out pretty well. Maybe just a little loss of detail in the upper left there. But overall, you know, for 1 minute 45 seconds on a black and white dog tag to have an image like that, pretty impressive. And just an example of what you could do kind of on the fly, maybe at some trade shows and such. All right, so over here on the laser, I went out into the yard and we have a lot of limestone sedimentary rock here in southern Minnesota where I'm at. And tried to find one with a fairly flat face because this laser will get out of focus very quickly. But sedimentary rock is fairly porous and not overly dense. So I'm curious to see if we can engrave a fossil on here. So I got this idea from one of the viewers, Jack. He's got a much better laser, fiber laser and whatnot, but wanted to play around with this. So I've got it set up here in Lightburn. I went ahead and found a fossil image, traced it, did some tweaking with the nodes and such to get it all joined into this. Now I've set this into a fill mode and I'm going to adjust this. So let's see here. We are going to want a max power of 100%. We are going to be blasting this thing. We are going to be going at 20 Hertz. I'm going to go ahead and cross hatch this. And, you know, I'm just kind of spitballing here, but I'm thinking it's going to take us a little bit. So I'm going to want maybe not the fastest speed. And then I'm going to crank this up to, say, 3 passes, and then I'm going to change the angle to about 25. Well, let's do 35 degrees. We're going to reduce our line interval to 0.05. That'll give us about 500 lines per inch. So hopefully that, between all those, hopefully that gets us somewhere. So once again, I'm going to turn on my air filter fan here to see if we can remove some of the debris. Let's go ahead and frame this so we can kind of see the rough image it's going to show up on there. And we'll see how, I tried to get this as level as I could. We'll see how well it functions. So let's go ahead and hit start and see where we end up with. So there you can see, we got a little bit of the effect. It's kind of half burned, half etched into there. You know, this is going to mix, your results are going to vary based on the type of rocks and your speed settings, but something you can definitely mess around with some people at the local lake with by engraving some rocks and tossing them back in. So we've played on a lot of metals and we've shown that organic material such as wood doesn't work very well with this. However, you can work with some plastic. So I do have some cast acrylic here, and this is a solid black and not translucent or clear. If it's clear, you're not, or transparent, you're not going to be able to engrave it without a medium to interact with. But we're going to get the shot on this black acrylic. Just keep in mind, anytime you're burning plastics, you really want to be sure what it is, make sure that there is no off-gassing that is going to be poisonous to yourself, your others, or dangerous to your machine as well. So be sure you understand the plastic material, or really any material, and any sort of hazards with burning it as you're working with it. So let's throw this on the laser and see if we can etch this as well. All right, so over here I've got the acrylic loaded, we've got it focused, and over here in Lightburn, I'm just taking a guess here, we are going to adjust this down to 2,500 millimeters a second. We're going to go with 100% power, 20 kilohertz, and we're going to go 0.1 millimeter on our hatch. We will also go ahead and cross hatch this And we've just got my shop logo here. So let's go ahead and frame this, of which it's faint, but we can kind of see it there. So I'm going to go ahead and slide that over, and we'll go ahead and hit start right after I turn our air, because this will have some fumes with it. And let's see what it does. That came out beautifully. That is very crisp contrast, very clean letters. I am very impressed with that. That is awesome. So if you were doing keychains, now you're not gonna be able to cut this out with this laser, but if you have some blanks, or if you have your CO2 or diode laser that can cut through this, you could get some very high contrast on acrylic with this machine. All right, so looking for some more practical things that I might do on this, I did pick up some of these brass challenge coin blanks on Amazon. These are about 40 millimeters in diameter. And before I go running them on those, I used a piece of brass sheet, and I ran a number of